Swayam Prabha. Digital India. Educated India.
A very good morning, good afternoon, good evening to all my dear friends and students who are taking this course TQM 1. I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we were discussing about the tree diagrams and the concepts, very simple concepts, even though I mentioned it very fleetingly about PERT and CPM, and I did mention words like JERT and QJERT. I would not go into the details, but I will just briefly consider the PERT and the main ideas, and for CPM also. So, how to use the arrow diagram? So, they were under the broad heading of arrow diagrams. So, list all the necessary tasks in the projects of the process. So, if you remember, I did mention the word of Gantt charts. So, Gantt charts are basically the preliminary work you have to do in order to basically draw this PERT and the CPM or the arrow diagrams to the best possible extent. So, determine the correct sequence of tasks. So, that would basically be coming out from Gantt charts. Create a table with 4 columns, which are the priority task, this task, the simultaneous task and the following task. So, what are the priorities, how they are related, what is the number of days which are required for the jobs should be noted down. So, diagram the networks of the tasks. So, time should flow from left to the right, as I mentioned or as you have seen for the tree diagram. So, the example which I gave for the tree diagram was from the top to the bottom. For the example which is shown on the slide was basically from the left to the right. So, in this arrow diagram, it will be from the left to the right, starting from the source to the sink or the start job to the end job. Time should flow from left to right and concurrent tasks should be vertically aligned. So, if you are trying to basically start 3 sets of job at the same time. So, if I am basically starting from the left, so this is job 1, I am marking as 1, and if job 2, 3 and 4 are starting on the same time, so they would be vertically aligned. Then say for example, you may have job 5, 6 at the same time, so they are related like this. So, they would be concurrently done and it will continue in this manner. Between each task, draw circles for events. So, again let me mention PERT and CPM technically, or the arrow diagrams or the precedent diagrams can be the overall event or the job can be on the arc or on the node. So, they would be activity on arc and activity on node concepts, but we are not going to go into details in order to understand, but the basic concepts always remain the same. So, look for 3 common problems, situations and redraw using dummies or extra levels of job implications. Dummies are actual events which are not happening, but they give you a relationship between the events of the jobs which are actually happening. So, dummies are given by dotted arrows. So, in the last slide I had shown the relationship between task 1 and task 2 or task 3 and task 4 as bold arrows, but in dummies they would be dotted arrows. So, 2 simultaneous tasks starts and end at the same time and use a dummy or an extra event to separate them. So, this basically this dotted one is the dummy one. So, this is basically the dummy activity which I am talking about. It would have no time as such assigned to it, but it will give you the relationship between the activities which are there. Now, task, so if I consider this to further on to consider, task C cannot start until both task A and B are complete. Fourth task D cannot start until A is complete, but need not wait for D. So, basically C depends on A and B, D depends on A, but has no implications of B. So, if you basically do this, you will basically have the dummy concept which is shown in figure 2 in the part of the diagram which is in the bottom half of the slide. So, it will basically you will notice that A and B are running so called simultaneously. D would definitely have to be done after A. So, this is shown here, and if you consider the B and D, the relationship, the dummy job does not go from my right to the left, because it clearly mentions that D has some relationship with A, but has no relationship with B. But on the other hand, if you consider C, it is noted down very clearly that C would have a relationship with A and B. So, that is why as you link up B and C, obviously the implications of A should also affect C. That is basically coming through the dummy diagram, which is basically from the left to the right. So, as shown in this slide and the bottommost diagram. Dummy events to continue further on, or second task can be started before the part of the first task is done. So, what you do is that add an extra event when the second task can begin and use multiple arrows to break the first task into 2 sub tasks. So, in this case what you have is basically A and B are there, and what you do is that you break them into nodes further on, not to complicate matters, but to understand what is the sequence of the events which are there. So, what you have from 1 to 2 you go is basically so called A, and then B branches out to basically continue to 3. So, what you do is that you have some part of A. So, it is basically the A work which is happening. You start, you go to the stage 2 or the node 2, and from node 2 you branch on further on for A to continue and B to basically take you from the node 2 to 4. So, it can be made more level of sophistication can be done, and you can basically draw the overall precedence diagram using the activity on arc, which is activity on arc or activity on node diagram concept, and the different ideas of precedence diagram as I mentioned can be PERT, which is program evaluation review technique. One is the critical path method, you have basically a JERT method also, you have the Q-JERT method also. So, they can be utilized in order to understand the concepts of different arrow diagrams. So, these are just for information, I am not going to discuss them in details, because this is not a part and parcel directly for the TQM one. Somebody is doing project management one, obviously this PERT, CPM, JERT, Q-JERT would be important. Continuing further for the arrow diagram, when network is correct, label all events in a sequence with event number in circles. It can be useful to label all tasks in sequence using the letters. It can be A, B, C, D, or it can be 1, 2, 3, 4. Once this is complete, CPM or the critical path method as I was discussing can be used for scheduling the task. Let us look at some basic steps and terminology related to CPM also, and obviously they can be extended to the PERT concept also, but for our timing we will consider the CPM only. In critical path method, you basically determine the task times, that is what is the time taken to finish them, determine the critical part which is the longest part from the beginning to the end. So, if you basically have the source where you are starting from, and these are the jobs which you are trying to do. So, this is 1, and then you will have 2, 3, 4, 5 till the last one, which I will use the word as S. S basically means the sink or the end, E is for end. So, I am using a very simple notation to give the example. So, they can continue like this, jobs are there, they are connected to each other, and further on this relationship continues in such a way that you continue the relationship till you reach the end. So, you have basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So, the diagrams I have not drawn, I am just showing few of them what is the relationship. So, from which stage to which stage they proceed. So, once you have that, all the nodes would basically have the time, what are the relationship between them, what are the actual durations which are happening, and once you find out, you try to find out what path will take the longest time. So, that is known as the critical path. So, this is what the second bullet point says. Determine the critical path, which is the longest path from the beginning to the end of the project. Length of the critical path is basically sum of all the task times for all the paths or the activities which comprise the critical path. From this, what you do is that you have basically the concept of trying to do the forward pass method or the backward pass method. That means, you try to find out the so called slacks, total slack and the slacks which are there for the job starting from the left to the right, and again do it from the right to the left, which are basically the forward pass and the backward pass method. Once you do that, you are able to find out the earliest start, the earliest finish, the late start and the late finish. When you do that, you will basically have in a table format for each job the earliest when they can start, earliest when they can finish, latest they can start, latest they can finish. And once you have this in 3 or 4 different columns in the chart, I am not giving an example in details here, you will be able to find out what is the slack, the free float and the total slack which is available here. Start with the first task where earlier when the early start is 0, for subsequent task you find out the early start which is the largest earlier finish plus of the task leading into that one and add up the time taken to do the job. You continue doing this, as I mentioned, you will have 4 or to 5 different columns with all the informations. Calculate the latest time each task can start and finish without upsetting the project. Based on this, on how long later task will take, these are called the latest start and the latest finish, which I have just mentioned few minutes back. Start from the last task, which is from the right, when the latest finish is the project deadline, and work backwards till you reach the source, which is job 1 or the point where you are starting. So, latest finish is basically the smallest LS, which is the latest start for all the tasks immediately following this task which you are trying to analyze. Latest task start would basically be the last finish minus the task time for that activity of the job or the time taken. Calculate the slacks, there would be one total slack, one will be free slack as shown here. So, I am just reading out what actually the total slack and the free slack means. Total slack is the late start minus the early start, or exactly it is equal to the late finish minus the early finish, and the free slack is the earliest early start for all the tasks immediately following this one minus the early finish. So, once you have this, you will be able to get the critical path and all the information. So, the process decision program chart is basically where the systematically it identifies what might go wrong in a plan under development, and basically you analyze that. And when do you use the process decision programming charts? So, these are not standalone, like this PDPC or the tree diagram or the precision diagram or the cause effect on one are different ways trying to analyze the problem, like the brainstorming sessions and the matrix concept. All these things are collectively utilized in order to analyze the problem into its utmost detail. So, continuing where to use PDPC, they are used when implementing a plan, especially when the plan is large and complex and there are different type of relationship between them. When the plan must be completed as on time or on schedule, when the prices of failures is high, or when the project is identified as risky, you take the decisions accordingly. PDPC procedures are obtain or develop a tree diagram for the proposed plan, that is high level of diagram showing the objective, a second level of main activities and the tertiary levels are done accordingly, which gives you the level of importance for each and every the so called work or the activity or the plans which is there for the task. For each task on the third level, brainstorming is done and trying to analyze what are the problems. So, you go to the fourth level, the fifth level, and then continuing the same sequence of analysis. Review all the potential problems and eliminate any that are improbable or they are not actually happening, and try to tackle all those things which can be handled in order to reduce the cost. For each potential problems, brainstorm possible countermeasures and take actions and basically write down or understand them how they can be tackled. Decide how practical each countermeasures are, or they can be taken into consideration, and you basically make a plan of action for that. So, a typical PDPC example is given where it is basically chronic illness management programs you are trying to do for the hospital. The patient self management support is there. So, the patient classes, their record keeping, and what the patient wants to, what you want to achieve for the patient, whether he is suffering from say for example fever, or if the problem is related to the heart, or the problem is related to some skin disease. So, all these things are considered. The age of the patient, what medication he or she is going into, what is the genetic profile of the patient, and all these things analyze, whether they are history of ailments for the patient. Then you basically have a decision support of the information set, which is basically collated and gets all the information of the patient, and then you basically try to design a deliverable system such that you can monitor the progress of the patient and take actions, what drugs should be given, which doctor should visit him or her, how the medication should be taken, whether the person should be put in the ICU, or the person should be put in the actual normal room, whether some preventive quarantine mechanism need to be taken for the patient if he or she is suffering from some disease which can spread very fast. So, all these things are analyzed, and once you have that, you basically get the nurse guidance and approval, checklist for possible medication things, and what are the financial implications for the patients, and the innovative staff rules and how they can be analyzed. All these things are done accordingly. So, these are the few of the references for these areas of fishbone diagram, tree diagram, PDPC diagrams, concepts, the matrix analysis, the precedence diagram. So, one can go through either the Wikipedia or the different books are there, and one very good book, just I am mentioning, nothing to do with total quality management, a book which is there in the market which one can study in order to analyze the precedence diagram. The PERT and CPM is known by the authors which have been written by both of them, which is Levy and Weist. So, this is PERT, CPM and precedence diagram is available in the market, and one can have a look and in these areas. So, continuing our discussion for quality, now we'll even though it's the lecture number is the same, we'll start a different area of the concept which is basically known as quality function and deployment, or QFD. QFD is a structured method that is intended to transmit and translate customer requirement. So, that is what is the voice of the customer, what the customer wants. Is it related to quality, is it related to cost, is it related to delivery of products right on time, is it related to after sales service, what it is you need to understand. Through each stage of the product development and the production process, the voice of the customer is analyzed. Now if I am the design person, for me the customer is not the customer to whom the product will be sold. My customer would be the sales, the person who is there on the shop floor, who will be utilizing my design and trying to utilize the raw materials which has been supplied to him or her and take the product. So, I will basically try to get the feedback from my customer and who may be internal for me, and try to analyze where the problem lies, how it can be improved. That means, the problem can be rectified. These requirements are the collection of customer needs, including all satisfiers, whether they are problems, whether they are dissatisfiers, or what are the issues and how they can be tackled. So, you do again an analysis and try to go into the root cause of what the problem is and take corrective actions accordingly. When QFD is appropriate or applicable, poor communications and expectations lost in the complexity of the product development. So, here rather than analyzing the macro level, you will go into the micro level and try to analyze the QFD for each stage. Lack of structure or logic to the allocation of product development resources are there in many of the cases. So, you will try to utilize the QFD in order to understand who are the customers and how the customers are affected by the so called vendor. The word vendor I am not using in a very specific term, is very general. So, if the customer in the shop floor, as I said, and for him or her the main supplier or the vendor is basically the design team, then you need to basically understand the whole sequence of flow of work which is happening between the design and the shop floor person. Or say for example, it may be that the salesperson who is basically the customer for the product which is coming out of the shop floor, and then the salesperson has to sell it to the customer. Customer means the end customer, and gets the customer feedback or try to design the customer after sales services. So, those would be linked in such a way that you will be able to understand what is the flow process of the so called responsibility, and how the work being done in what's first stage affects the work which is to be done in the second stage, such that the output for second stage becomes the input for the third stage and carries on accordingly. Lack of efficient and or ineffective product process development teamwork, if it is there, then it basically entails the appropriateness of the QFD. So, extended development time caused by excessive redesign, problem solving or firefighting issues are very important, which should be considered when you are trying to analyze the QFD issues, whether they are important or not. So, a very brief history of QFD. So, origin of QFD or how it can be utilized is basically comes from the Kobe shipyard, Mitsubishi Kobe shipyard, and started in around about 1971 and 72. It was developed by Toyota and its suppliers, expanded to other Japanese manufacturing related to consumer electronics, home appliances, clothing, integrated circuits, apartment layout planning, whatever it is. It was also adopted in the end of about 10 years from 1972 in 1980 and 81 by Ford and GM, and by other players in the market related to Hewlett Packard, AT&T, ITT, and so on and so forth. So, foundation is that believe that product should be designed to reflect the customer design and taste rather than your taste, who is basically the supplier. So, you are basically the supplier of the product or the design or the equipment or the services to the customer, who should be satisfied. So, quality functional deployment, house of quality, if you consider, so it basically would consider consist of the following one. So, you have the diagram here in front of you, it basically gives you the house of quality. So, it will be the main focus which we are trying to analyze is the relationship between the customer needs and the design attributes, whether the designs which you as a company are is making, whether it meets the criteria of what the customer wants. So, there would be some customer perception, based on the customer perception the design attribute should be tailored to. There would obviously be some cost feasibility concept, engineering measures. If the design requirement based on the customer requirement is very tough, then obviously the cost would increase. So, you have to basically make appropriate planning in order to meet the customer requirement to the maximal possible extent, and if required obviously you have to talk with the customer and try to check that how rigorous or how good or bad the requirements which the customers are is actually needed at his or her end. So, there would be the design attributes, there would be importance of ranking, the customer needs, everything is combined in order to find out the relationship between the different points which basically makes the house of quality. So, it basically establishes the flow down, flow process and what is the relationship, relates to what's and hows and how they are related, ranks the level of importance such that one can take a rational decision, what is the relationship between the customer, his or her demands, the cost factor, the design factor and the needs of the customer, and all these things can be considered. So, the house of quality basically would have a set of key elements and the informational elements made into a matrix form. So, the two types of elements in each house basically are clubbed together such that you get the maximum information by the relationship which is given by the matrix. So, the QFD flow down would be basically for this concept which you are considering would be the manufacturing environment, would be in the software environment, would be in the service environment. So, the customer would have some wants, based on that you will have some technical requirements, there would be smart characteristics given for each and every equipment or the subgroups which are going to be combined in order to make the product which the customer wants. There would be manufacturing process specified for that, there would be production requirements also specified for that. So, obviously, when you come to the software environment, it would relate to customer wants, product functionality, systems characteristics and design alternatives. Similarly, there would be service environment related to customer, service, processes and requirements and process controls. So, when you are trying to build the house of quality, the main points which you should consider and obviously emphasis should be laid on would be like identify what is the customer attributes, what does she wants, what are the tangible and intangible benefits the customer wants, what are the tangible and intangible benefits or the working of the product which the customer is requiring. Say for example, in a restaurant you are able to supply, say for example, some vegetarian food, but if the customer wants less oil or more chilies or less of vegetables, obviously you have to meet the criteria as the customer wants and tailor your production process. Production process means the process how you are making the food accordingly. Identify design attributes and requirements which have been stated, like requirements that the customer wants, that he wants hot food or he wants less oil or he wants no milk. So, all these things should be considered. In case when you are trying to basically sell a car to a customer, the customer wants consider that he or she wants that the luggage space for that particular car should be better, or say for example, rather than the bucket seat in a big SUV, the customer wants a continuous seat. So, you have to basically make those adjustments accordingly. Or maybe say for example, the customer wants that rather than having child lock only at the back doors, it may be possible that the customer wants a child lock in all of the 4 doors. I am just stating some facts which may be very important points for the customers, and they have to be taken care by the manufacturer or the service provider who is basically giving the services or the product to the customer. Conduct an evaluation of competing products which are there in the market and try to see that whether those products would be able to meet the customer requirements, and whether you need to basically change your overall process of manufacturing the product or trying to basically give the services to the customer such that you are able to meet the customer requirement to the maximum possible extent. Evaluate design attributes and develop targets for each stage of the work which you are trying to do. Determine which design attributes to deploy and in the remainder of the process, and how these different type of attributes are basically giving the overall throughput based on which you are able to satisfy the customer demands in the long run. So, that means customer wants a product, and whether the product is able to meet all the design specifications or the working specification based on which the customer has ordered that product to you. So, when you are identifying the customer attributes, these are the product or service requirements in the customer terms. So, the customer has said I want a blue colored car, or the customer says that I do not want the child lock to be present only at the rear doors, they should be present at the 4 doors. Or say for example, the customer wants the headlight rather than having some wattages of bulb, it may be say for example, he or she drives along the highway in the night. So, obviously, the requirement for high beam light is important. Or coming back to the same example, say for example, you are serving food and the person wants, as again repeating the same example, it may be less oil, less chili, or more oil, more chili, less salt, whatever it is, you have to basically meet that criteria for your product or services based on the customer terms specified by him or her. So, they would be collected and analyzed through market research, surveys and focus groups. So, if I am trying to sell a product like a fridge or a refrigerator or a washing machine or some car or some mixie in the market, I will try to basically get the customer feedback. Based on that, I will try to analyze and make my product accordingly. So, you will try to understand what does the customer expect from the product. Why does the customer buy the product? Is it absolute necessity, or is it that the customer has some requirement, he or she is not able to get that from the market, or the costs are higher for your competitors, that is why he or she is buying that product, or is basically an one of a kind product which you as a company can make it. So, is it based on that fact that the customer has come and stated the requirement for the product. So, you have to basically analyze this accordingly. Salesperson and technicians can be important source of information. So, if the salesperson goes for doing a survey, he or she will get different set of information qualitatively. You will try to analyze and collate them and try to go into the depth of the analysis of the data which you have collected through your salesperson, through your technicians, in order to analyze that where the requirements of the customer is. So, those salespersons and technicians would basically be the best source of information, both in terms of these questions and in terms of the product failure and the repair or the after sales services concept which are there. Often these are expanded into secondary and tertiary needs and requirements, such that you are able to analyze the problem. No, I will not use the word problem, the requirements more in depth. So, the key elements of what's are, if you basically trying to analyze the voice of the customer, it would be what does the customer want, what are the requirements, what are the customer needs. So, does the requirements and the needs match? If not, obviously you can as the supplier of the product or supplier of the services, you can basically state in the terms of what the customer needs. So, all these requirements and needs are basically collated in a matrix formulation, such that you are able to understand what is the linkages and how the relationship holds between different type of customer requirements and his needs and wants in a very simple manner. So, continuing with the voice of the customer. So, how important are the what's to the customers, and what the requirements are he or she has placed, and whether he is able to meet the requirements. You will analyze them again, do a ranking, combine them in the matrix formation, and continue doing this in such a manner. It will give you a much better understanding what the requirements of the customers are with respect to his or her needs. So, with this I will end this lecture and continue the voice of the customer and the QFD concept in more detail, and then we slowly go into the different quantitative parts, which would be one of the main important focus of the TQM1 course. Have a nice day. Thank you very much.